Chapter 9, Data Design. This chapter focuses on the data design skills that are necessary for a systems analyst to construct the physical model of the information system. Chapter Objectives. Describe data relationships. Draw an entity relationship diagram. Define cardinality and use cardinality notation. Explain data control measures. Data design concepts. Data structures. Framework for organizing, storing, and managing data. Comprises of files or tables that interact in various ways. Each file or table contains data about people, places, things, or events. Data design concepts. The database environment. Database management system is a collection of tools, features, and interfaces that enables users to add, update, manage, access, and analyze data. Database management system advantages. Scalability. System can be expanded, modified, or downsized. Economy of scale. Database design allows better utilization of hardware. Data design terms, key fields. Primary key, field or combination of fields that uniquely and minimally identifies a particular member of an entity, called a combination key. Candidate key, any field that could serve as a primary key. Foreign key, field in one table that must match a primary key value in another table for a relationship between the two tables to exist. Secondary key, field or combination of fields that can be used to access or retrieve records. For an illustration of the key fields, see Figure 9-10 in Chapter 9, page 284. For additional content about the key fields, review pages 283 to 285. Data design terms, referential integrity, is a set of rules that avoids data inconsistency and quality problems. For more information about referential integrity, read the content in Figure 9-11 on page 286. Entity relationship diagrams. Drawing an ERD. List the entities that were identified during the systems analysis phase. Consider the nature of the relationships that link them. Types of relationships. One-to-one relationship exists when exactly one of the second entity occurs for each instance of the first entity. One-to-many relationship exists when one occurrence of the first entity can relate to many instances of the second entity. Each instance of the second entity can associate with only one instance of the first entity. Many-to-many relationship exists when one instance of the first entity can relate to many instances of the second entity and vice versa. ERD continued. Cardinality describes the numeric relationship between two entities. Shows how instances of one entity relate to instances of another entity. Crow's foot notation indicates various possibilities using circles, bars, and symbols. For more information about entity relationship diagrams, review the content and figures on pages 287 to 290. Data normalization. Normalization process of creating table designs by assigning specific fields or attributes to each table in a database. Table design specifies fields, identifies the primary key in a particular table or file. Stages in a normalization process are unnormalized design, first normal form, second normal form, third normal form. Data normalization. First normal form does not contain a repeating group, converting an unnormalized design to first normal form requires expansion of the table's primary key to include the primary key of the repeating group. Data normalization. Second normal form, examples of a functional dependence. Field A is functionally dependent on field B if the value of field A depends on field B. A table design is in second normal form if it is in first normal form. All fields not part of the primary key are functionally dependent on the entire primary key. Data normalization, third normal form. A design is in third normal form if it is in second normal form and if a no non-key field is dependent on another non-key field. This avoids redundancy and data integrity problems that still can exist in second normal form designs. For more information about data normalization, review the content, figures, and cases on pages 294 to 304. Data storage and access. Logical versus physical storage. Logical storage is data that a user can view, understand, and access regardless of how or where the information actually is organized or stored. Physical storage is strictly hardware related. It involves the process of reading and writing binary data to physical media. Data control. A well-designed database management system must provide built-in control and security features. Forms of data protection, providing limited access to files and databases, use of user ID and password, permission, and encryption. Backup copies of databases must be retained for a specified period of time. Recovery procedures can be used to restore the file or database. Maintain audit log files and audit fields. Chapter summary. An entity relationship diagram is a graphic representation of all system entities and the relationships among them. Relationship between two entities is referred to as cardinality. Normalization is a process for avoiding problems in data design. File and database control measures include limiting access to data, data encryption, backup/recovery procedures, audit trail files, and internal audit fields. Make sure that you read Chapter 9 and review the key terms.